Hi, I'm Oliver Nowak from RWTH Aachen University. With my colleagues Lennart Becker, Sebastian Pettirsch and Borchers, I would like to present our work, Mappings in the Home, selecting home appliances in 3D space. In a smart home, we use smartphone apps or voice assistants to control individual devices. While they require having a smartphone around or loud commands to the assistant, we propose integrating tangible controls into the environment that offer subtle input, are located where they are needed, and are usable for people unfamiliar with the system. However, with an increasing amount of appliances, fitting controls for each device onto a surface becomes impractical, making it necessary to select appliances before controlling them. Looking at our living rooms, we see that home appliances are arranged in 3D space, while our environment often only provides two-dimensional input surfaces. Therefore, when creating controls that use spatial analogies and, for example, show a room from the top, the mapping gets complicated and the devices can occlude the ones underneath. We explored 6 controllers to overcome this. Map Repeated Clicks provides a room map from the top, where users can use repeated clicks to iterate through the targets above each other. Map Levels separates the room into 3 height levels, approximately at hip and face height. A repeated clicks controller was used for each layer. For map frames, if targets are vertically stacked, their buttons are placed below each other, but a frame around them indicates that those are at the same horizontal position. Map 3D resembles the room using pillars. This is the only controller that implements a direct 3D to 3D mapping. With perspective button and perspective touch, users first choose the direction of the target relative to their position, and then select the device according to its height in their field of view. Looking at this scene with a ceiling light and smart blinds on the wall, the outer button or a longer swipe would select the closer light as it is higher in the user's vision. We tested those controllers in a user study, where people selected targets once while the controllers were visible and once eyes-free. Our participants did not like controllers that separate the room in any way. In particular, perspective button performed badly due to its directional separation of the room and the used projection. Although perspective touch uses the same projection, this controller was ranked very well due to the feedback targets needed to provide for this controller. Only map frames was ranked better.